Thank you. Hello, everybody. My name is Dylan Plantinga.
I'm Joshua Sheldon. Thank you all for coming.
Today, we'll be discussing the effects of temperatures on the growth rate of dietary habits of white sea bass.
My bad, sorry.
So you might be asking yourself, what is a white sea bass? Well, put simply, it's fish. But more importantly than that, it is the largest species of growth around the California coastline. It's got this amazing silver and white coloration right here. And their broadcast waters, you can kind of see on the end there of that diagram. So many individuals, both sexes, will move into the shallows, release gametes, and that'll be following seed spry. So some natural history on them. They're ranged all the way from Alaska down to Mexico. So they're all down our western coastline. They've been a valuable food source for travelers since the early 19th century and still are to this day, as you can see over there. And they were overfished heavily from the 60s and 70s with the advent of modern gill nets, which are pretty much invisible to the beach. So some conservation efforts. As soon as we started to realize how much of a blemish that those gill nets were doing to the population, reducing those fisheries for the fish count from 62,000 individuals per season to 600 individuals per season, they immediately eliminated those gill nets, and then they started to rehabilitate. And first key players in that, still to this day, are Hubs, SeaWorld Research Institute, which I'll refer to as Hubs in this presentation. They began catching broodstock, so large sexually mature males and females, breeding them at one site, and then raising the fry and releasing them into the wild, in turn supporting the population. We see that this works because recent studies that were recent in 2022, you can see that nearly 50% of our populations up here on our California coastline actually tie back and have lineage to individuals that were kept at Hubs. So very, very successful program. So successful that their conservation status was changed over the past 30 years from a species that was endangered to something that is now a species of least concern. So very helpful. And with that, you might be asking yourself, what's the problem? Well, guys like this. Not only sea lions, but a slew or myriad ocean, if you will, of other predators that could predate on this fish. And with that being said, fish are often a microscopic scale, so you have to imagine every little bit counts. So that raises the question, can we grow them any faster? So some important things to note is each year we release hundreds from our school, Orange Coast College, in addition to many other schools in Orange County and Southern California area. And in addition to that, on the grand scale, you actually see Hubs releasing, still to this day, thousands of specimens each year, which is hugely important. So any little bit could save us, potentially on a grand scale, hundreds of thousands of dollars. You actually see on the upper right-hand corner there that some of our classmates in a recent season releasing their white sea bass. Barely see those little guys in the bucket, but we have a little white sea bass being released out here. Another potential predator for those guys, California black dog. So, something to note about these guys. They are cold-blooded fish, also known as exothermic fish. But with that being said, they are very dependent on their environmental factors, in particular, temperature. If you have a cold temperature, their bodily functions are going to follow that pattern. They're not going to grow very quickly, and they're going to consume less food. Now, on the larger size, or on the warmer side of things, you start to see order fish reach larger sizes, at a quicker rate over the same amount of time. So in our study, you'll notice that we follow appetite as an indication of potential growth rate, which we follow multiple studies that do show a clear distinction or a relation between consumption of food leading to a larger growth rate in the same period of time. So our hypothesis, to be clear, is that when kept at a temperature higher than the standard temperature we keep them in at the Orange Coast College Dennis Kelly Aquarium, yes, we do have an aquarium, there was that don't know. They should really reach a larger size in the same period of time. So some key materials we utilized for this project are a 40 specimens given to us by Hubs, same place we talked about earlier, 20 per tank, or 75-gallon tanks per group, so 20 fish per 75-gallon setup, filtration and chillers to make sure the water parameters maintain a very precise set of parameters, if you will. And colorimeters keep track of those counts, make sure that we don't have any toxins in the water that could potentially harm our fish and your project. And then the fish feed was also given to us by Hubs Secret Research Institute. As you can see, that they're set up there, filtration, feeding and colorimeter. So this is our specialties data release after an hour-long acclimation period. This acclimation period allows us fish to make sure that they are not being introduced to any new stresses. Potentially, for example, if you were to take a fish from 55 degrees and drop it into a 65-degree tank, it would suffer stress due to those environmental factors. So we acclimate them in an hour period of time, as we see here. After their hour acclimation period, that's how they release some area ticks. So our methods started with a 7-day trial period after they were allowed a couple weeks to get used to their new homes. The fish were fed to satiation once per day. For those of you that do not know, fed to satiation is pretty much as much as they're willing to eat. So we gave them as much as they're willing to eat. Once they stop eating, we cut them. Fish waste, excess food was removed from both tanks at the end of every day's final feed to make sure we don't have any kind of toxins released in the tank. And a precise amount of food was calculated each day by observing the initial weight of the food, the amount they were given, and then deducting any leftover pellets we found in the tank that could potentially take away from that total eat. Water changes were performed about 2 times throughout the 7-day period. The tanks were kept at a 59-degree Fahrenheit and 65-degree Fahrenheit each time. Thank you.
Let's talk results. Here is a table of the total amount of food eaten between both groups. Highlighted in pink here is our totals for the warm group, 42.82 grams over our 7-day trial period. The cold group ate 31.01 grams of food over those 7 days as well. This is that data graphed onto a table. Red is the warm group, blue is the cold group. As you can see, the warm group ate consistently more than the cold group every single day. These are averages for our feeding data, and in pink is the average mass eaten per fish per day, and that is the most important metric we have here. Every fish in the warm group ate an average of 0.31 grams of food every single day. Every fish in the cold group ate 0.22 grams of feed every single day. We can calculate that every fish in the warm group ate 41% more food every day on average than the cold group. Unfortunately, though, we ran into some unforeseen issues. On April 4th, we started seeing signs of stress from our fish. These include labored breathing, lethargy, and a reduced appetite. In fact, we couldn't get them to eat at all. On April 5th, we began troubleshooting this issue with increased air input into the tank. We thought that perhaps there was oxygen issues with the water. Upon water quality testing, though, we discovered that oxygen was not an issue. And because of that, we performed large water changes to try to mitigate other issues. On April 6th, we suffered our first loss of life. And over the next 2 days, all but one of the fish passed away from the cold group. Our one surviving fish is currently residing in OCC's Dennis Kelly Aquarium quarantine tank, where it is doing just fine. That is this one right here, doing all right. And then this is one of the fish that was exhibiting that lethargy and that labored breathing. Another thing to note is that the warm group of fish was totally unaffected. We have to ask ourselves, why did this happen? We have several theories. Our most probable cause of death is prolonged ammonia exposure. To give a brief summary of what goes on in aquariums, fish and other aquatic organisms are secreting waste all the time as they're breathing and eating. And this waste is most common in the form of ammonia, which is a nitrogenous compound. Aquatic organisms rely on populations of bacteria living in the sediment and on surfaces to take this ammonia and transform it into compounds that are less toxic. We theorize that due to having 20 fish in our system, our bacteria was not sufficient at processing this ammonia. In addition, you'll notice that we have these tables here where you'll see the cold group ammonia in blue, warm group ammonia in red. For an entire weekend longer in the cold group than the warm group, the fish were experiencing higher ammonia levels. From March 29th to April 1st, there's a large discrepancy in ammonia levels. Our response wasn't as effective as we wanted it to be, and there are a couple reasons for this. One of them is that we were afraid of derailing our experiment. If we were to take our cold group fish and move them to a quarantine tank, we would have had to stop collecting data on them altogether. The other thing was complacency. Our ammonia levels were moderate to high, but they were consistent, and we thought that these fish could handle them. Unfortunately, it was the prolonged exposure that did them in. We were unable to get final weight on the cold group, meaning that we have nothing to compare growth data for the warm group to. And in that case, our only data that we can present on is food consumption, which you guys have already seen. So what do we do now? In the wake of our loss, we struggled with the idea of what to do. We considered dropping the project. We wondered if it was salvageable. And looking at our food consumption data, we decided that we do have something worth presenting and that we should present and show people what we learned and what people in the future can do to perfect our experiment. We recommend for future studies that a smaller sample group be used. 10 fish is probably fine. Increasing the volume of each tank would further dilute the toxic compounds in the tank so that they are not affecting our fish as much. Creating schedules for water quality monitoring, water changes, and other longer-term maintenance would be extremely beneficial for anybody that's working on this project. In addition, more people working on the project would help us with our maintenance. We believe that our mistakes are an easy fix. Pictured here are plenty of students from Orange Coast College's Dennis Kelly Aquarium who are ready and hopefully willing to take this project from us and run with it in the future. We believe that if they take this project and they do something good with it, we can actually increase the growth rates of our fish and hopefully release them into the ocean with larger sizes, and then we'll be saving hubs lots of money and effort. Our food consumption data supports our hypothesis, which is really important to note for people interested in furthering this topic. And at the end of the day, the common theme in aquariums and in science in general is how can humanity coexist with nature? And this is one of the ways that we do that, by taking better care of our oceans and ensuring that there are healthy populations to exist in the ocean, but also enough for us to take recreationally and commercially so that we can continue eating these animals.
I'd like to give a special thanks not only to Hub, SeaWorld Research Institute for supplying us with these organisms as well as food and permission for us to study, but also the Orange Coast College Dennis Kelly Aquarium, because not only did they help us with allowing the space and materials needed for this project, but also some wonderful helping hands, which I actually see a few of in this audience. So thank you guys so much for all that help. Really appreciate it.